So today we're going to continue our discussion with quantitative displays. Yesterday we talked about how to create 3 of the different types of displays with histograms, stem plots, and dot plots. Now we're going to discuss how to describe. So we're going to start with some of the basics on how do we describe things. And as we can see here, we're going to focus on 3 aspects of it, which is going to be that shape, that center, and spread, or what the book is going to call variability. So when we look to examine a distribution or we want to describe what we see, we look for an overall pattern. So we kind of ignore ups and downs, we ignore small deviations from class to class, and we're really worrying about the big picture. Like overall, what am I seeing in terms of patterns and trends and things like that. Of particular note to us sometimes is looking for anything that falls outside the normal pattern or these outliers. So sometimes we want to look at those outliers a little bit more closely. Maybe the data was collected incorrectly, or it really is a standalone value, and we need to examine kind of why it's so different from what the rest of the data would have us see. And so those are some of the things as we get into this, like we talked about on that title slide. We're going to talk about shape, we're going to talk about center, we're going to talk about spread. And then outliers is another thing we comment on. So do we see any apparent outliers? Do we not see any apparent outliers? And all of that kind of gets taken in as part of our analysis for that overall distribution. So as we look at those major peaks, we try to ignore small ups and downs, focus on the big picture, like I said a second ago, and try to really focus on that overall pattern. So the first thing we're going to discuss are the outliers. So when I'm looking at a set of data and I look at the distribution that's created, so in this case a dot plot, it has the amount of added sugar in teaspoons in a single serving of several plant-based yogurt brands. So we just looked at how much sugar was added in these different yogurts. And as we look at the overall distribution, we notice that quite a bit of the data, a lot of the distribution is focused around this 1 to 4 tablespoons of sugar. But we do have a couple of outlying values or possible outliers. One of the yogurt brands adds 5 teaspoons of sugar, and then we have a couple down here that have 0 added grams of sugar. And so those 2 values fall outside the norm where we see the majority of the data centered at. And so those would be ones we would maybe want to comment on in part of our description. So as we're going through our shape, center, spread, we're looking at these outliers, we would want to comment on these brands and maybe examine them closer and see what's happening with those particular brands of yogurt. And so that's kind of what we're looking for, is just pieces that fall outside the normal range of what the overall pattern looks like. And so we can see those in a lot of different types of distributions. We'll talk about how to handle those in terms of calculating different measures of center and different measures of spread and things as we get into that particular topic. But for right now, we're just trying to get used to identifying and examining those different types of outliers that may be existent within our distribution. And so that's what we're always going to be on the lookout for. As far as shape is concerned, so when we're describing our distributions, there's 3 different types of shapes that we're really going to focus on. So as we look at the examples here, we have the graphs on the right. So that top graph is what we would call a roughly symmetric graph. And as you look at the definition over on the left here, a symmetric graph, just as the name implies, has left and right sides that are approximate mirror images of each other. So as I kind of look at splitting the graph in half, we can kind of see that the left side and right side are approximately identical. And so as we're looking at that top graph, we see that one peak alone in the middle. If we were to examine drawing a smooth curve to approximate, we see that that smooth curve would be fairly symmetric on the left and the right side. And so anytime we see that type of pattern, and unless we see a major deviation from that, we're going to say our distributions are roughly symmetric. And then if we do see that peak get pushed to one side or the other, so if it's not symmetric where the left and right side are pretty much identical, that peak's going to be pushed one side or the other. And so as we look at this second graph, we notice that the peak got pushed a little bit to the right, which is going to cause what we call a skewed left graph. And so what happens in a skewed left graph is that we have a peak that falls late within the data set, and creates an elongated tail along the left side of the distribution. So as I imagine that smooth curve again, we can see that as I create that curve, this left tail extends much further out than the right side. And so we call that a skewed left distribution. The easiest way to think about whether it's skewed left, or in a second we're going to talk about skewed right, is think about if I were a skier on top of the hill. So if I'm at the top of this hill and I want to take the safest route down the hill, I'm going to want to make sure I go the smoothest route, which would be the longest tail, and head to that left side there. Otherwise, the other thing we can encounter is if that peak gets pushed to the other side. So now we see in this bottom graph, we're going to be skewed to the right as that peak got pushed a little bit to the left. So in a skewed right graph, it's the exact opposite. The right side of the graph is going to be elongated compared to the left side. Again, trying to fit that smooth curve to it. We see how that peak starts early, and then we have that gradual fall off to the right side. And again, as a skier, if I wanted the safest route down the mountain, I would go ahead and head down that right side, which is why we call this skewed right. And so as we're looking at the different graphs, and we look at the either stem plot, histograms, dot plots, whatever the case may be, those are the kinds of things we're going to be looking at, is where does that peak fall? And we're looking at those left and right sides of the graph. So are they approximately identical? We can call it symmetric. Does the left side extend out further, or to the right side, and we get that skewed left or skewed right distribution? And so that's going to be one of the main topics or main focal points as we look at the overall pattern in graphs. Sticking with shape for a second, we also want to comment on the fact that those peaks that we discussed have different, or we have different graphs that'll have different numbers of peaks, or no peaks at all. And so just a quick little comment on a couple different things. All of the graphs we saw on that last slide were what we would call a unimodal graph, where we have a single cluster or peak that defines kind of the overall graph itself. And so as we see in the example up above that, we have one single peak right here at the 20, and then it kind of gradually falls off to the left towards the left edge of the graph there. And so that would be a unimodal graph, one single peak, versus the graph on the right side here, which we call a multimodal graph, or a bimodal, since this one has only two. Multimodal is just a little bit easier because it encompasses any number of peaks that we could create. But in this case, we have one definite peak or cluster here around 2, and a second peak or cluster right around the 4.5 range. And so in this case, we have two distinct peaks, which makes it a little bit harder to examine and describe, but we still would deal with that as a multimodal graph, having multiple peaks in play. And then the last type is what we call a uniform distribution. So if I ever see a situation where basically the frequency is pretty much identical all the way throughout the graph, that means that from one class to the other, or one category to the next, or that we go through, is going to be uniform throughout. So it's going to be roughly the same. So like rolling a die. When we roll a die multiple times, we expect each of the numbers to come up fairly equally, and so it creates what's called a uniform distribution. So this would also be something you would be able to use to describe, besides the skewed or symmetric nature of the graph, does it have one peak, multi-peaks, or does it have no peaks and it's approximately uniform throughout? So that's going to be our shape. So nothing to measure, nothing to calculate. It's just a matter of looking at the overall pattern and making a determination. When we get to the center part of the description, there's two different measures of center that we're going to eventually discuss and talk about. For today, like I said, we're going to keep things a little bit basic as we introduce these topics. And so the first thing we're going to talk about is the center that most of you should already know, called the median. That median is that midpoint of the distribution, is kind of the way we look at it. So we want the point that splits our data set into 50% of observations on the left, 50% of our observations on the right. And so what you're going to be doing is you're going to be looking at the distribution and determining where would that midpoint or balancing point within the graph be. So where am I going to find that exact 50-50 split between the left side and right side of the graph? So in the histogram that you see on the screen here, they kind of separated it out, color-coded already, but they're showing you that at right around a magnitude of 7, would be considered the center of the distribution. There's about 50% of earthquakes that have a magnitude less than 7 and about 50% that had magnitudes above 7. So we're just looking for that nice splitting point, that nice midpoint throughout the distribution. And then the other thing to mention as we're talking about that is when I do measure the median, when I do describe my distribution and I mention what that median looks like, making sure we use the same units as the data itself. So if I was measuring things in inches, my median would have a unit of inches. And if I was measuring things in pounds, the units would be pounds for the median as well. So every time I describe the center, right now, we're going to use the median, and then we'll add another measure later and talk about when to use each of those in one of our coming discussions. As far as variability, again, we're going to keep things pretty basic right now. There's going to be 3 different measures that we describe using variability. So it'd be the range, the IQR, and the standard deviation, all of which are going to have their own separate discussion, just like with mean and median, because we have to talk about how we calculate each value. We have to talk about when to use each value. So for right now, as we're keeping things a little bit basic in terms of the description process, when we talk about variability or spread, we're talking about how the data varies around the center. That's our entire goal. So I have that center value, that median for right now that we're talking about. So that would be the one number I picked to describe the entire distribution. And then I want to see, okay, well, how does the rest of the data spread around that? So how closely do we follow that, or how far away do we spread out? So we're looking for that variability. Whenever we do describe a distribution numerically, we need to make sure that we have a measure of spread as well as a measure of center always paired together. We won't be able to do that for these first couple of lessons because we're not going to talk about variability until we've talked about the whole idea of shape and then the whole idea of center, and then we're going to add in that variability as that last little piece that we can then put all together. So for right now, when we ask about variability, you're simply going to use that minimum and maximum value to describe the variability. We go from this value to this value with using the same units as in the problem itself. So if we were to look at a previous example here, so let's say we looked at the quiz scores here. So as we look at that quiz scores, we would say as far as shape is concerned, it's unimodal, skewed left because of that elongated tail on the left side. The middle would be somewhere around the 17-18 range. And we'd have the variability ranges from 13 to 20. And as far as the overall graph is concerned, there don't appear to be any outliers that stand out as it's presented in the graph. So that's kind of what we're going to be talking about, is like, how do we incorporate those 4 pieces of information as we describe. The other thing then, we talk about comparing distributions. So that we talked about this with the side-by-side bar graphs. We talked about it with the back-to-back stem plots. So most of the interesting statistics questions involve comparing 2 or more groups. When we want to make sure we're comparing the groups, we want to talk about shape, center, spread, and possible outliers for both. How do they compare? How do they contrast? So for example, if we look at the following distributions here, so separate random samples of 50 households from the UK and South Africa were selected. The distributions of the number of people living in each household is shown at the left. So compare the distributions of household size for these 2 countries. So if we were talking about shape, we would note that the South African shape is a little bit skewed to the right, so we have that elongated tail to the right. The center for the South African graph would be right around the 6 range. Okay, and we could actually count the dots to find the exact midpoint in this case. And so that median would fall right at that 6 range. And then we have a spread that goes from about 3 people living in the household to 26. As far as outliers are concerned, we note that there's definitely an outlier out at the 26, possible outlier here at the 15. And so we would make all those observations about that South African distribution. Comparing that to the UK then, we notice that the UK graph is a lot more symmetric. So we'd have a roughly symmetric distribution of household size. The median value would fall at 4. So the median household size would be 4 people living per household. And then the spread is also quite a bit smaller, ranging only from 2 to 6 people in the household. There do not appear to be any outliers anywhere in the data set. And so there's our comparison and contrast. right? So we measured shape, or talked about shape for both, spread for both, we talked about center, and then possible outliers. So you'd want to make sure to comment on all 4 of those and how they compare to the other. Same thing here then. If we're looking at back-to-back stem plots, same ideas, comparing the 2 distributions. We have both distributions are skewed to the right. So in this case, they share a shape. So we have our resting heart rate on the left side, our after exercise pulse rate on the right side. Both are skewed to the right. We have a median pulse rate of about 98 in the after exercise group. We have a median pulse rate of 76 in the resting pulse rate group. And then as far as the spread, we vary from about 68 for the pulse rate on the low end on the resting to 120 on the high end, and then about 86 to 146 on the after exercise group. And then the last piece that we would be discussing are those outliers. And so in this case, there's an apparent outlier in the resting group at 120, probably an outlier here at 146 in the after exercise. And so both seem to have an outlier on that high end for both distributions. So we can comment on all 4 aspects and how they compare and contrast within the groups. So in the homework tonight then, you're looking at the distributions, you're looking at describing. So it's describing shape. Am I symmetric, skewed? Am I unimodal, bimodal? We're looking at center. Where does that median appear to be? And then for variability, just kind of mentioning the minimum and maximum values to denote that spread for right now until we talk about more concrete calculations for that. So you can try those out, and then tomorrow we'll get into the measure of center a little bit more, and talk a little bit about median and mean, when to use each, before we start that conversation on spread as well. So you should be good to go with the problems on Google Classroom. And as you're working on those, just like always, if you have any questions, just make sure you ask.